This experimental setup is used to study Rutherford scattering. The apparatus used here is to simulate the structure of an atom. Now what Rutherford found through his experiment was that when electrons are passed through or they are shot at an atom, when he used alpha particle, what he call as bullets, he shot the alpha particles to the atoms of gold foil. What he observed was that on the screen on the other side, the electrons, the alpha particles did not come out straight all the time, but they deflected, and in certain cases they deflected backwards. This is what we call as the scattering, and it was in the effort to determine the structure of the atom. What Rutherford found out was that atom consisted of a nucleus, positively charged nucleus in the center, and the electrons are orbiting the atom. Bulk of the space in the atom are taken up by the electron, the orbit of the electron, and for that reason he stated that the alpha particles pass the atom undeflected. There were some alpha particles which were deflected, and he stated that were due to the positively charged nucleus located in the center of the atom. Now to demonstrate the model of our atom, Rutherford scattering, here we use a very simple model, a setup which constitutes of a hill, as you can see over here, and a path to project the ball bearing. The ball bearing here that represents the alpha particle that Rutherford used in his experiment. The hill here, it represents the structure of atom. Right in the center, the hilly portion that represents the nucleus of the atom, and this region represents the space taken up by the electron. Now in this model, what we do, we roll a bearing down the hill like this, down the slope. The height of the slope are varied. If I have the ball right on top, then it is the maximum height. Somewhere here the height is reduced. The height corresponds to the energy the ball bearing will have upon rolling down the hill. If I roll it from top, then it will have maximum kinetic energy, maximum velocity here. If I roll it from somewhere there, it will have less velocity. So the energy that you obtain by changing the height of the ball bearing will correspond to the velocity the ball acquires upon rolling down the hill. Some of the parameters that you need to measure here is B, which corresponds to the distance from the center of the hill on the other side. So if I move the slope more this side, I am increasing the B. B is from the center to there. That is how I will change my B. What you need to record is the angle which the ball bearing rolls down. Now I will show you, demonstrate to you the pattern that this ball bearing leaves on this hill which corresponds to the atom. I will release the bearing, it will roll down. There it goes. Okay, so it is very fast. It might not be easy for you to obtain the position the ball bearing leaves on this platform. So in order to do that, we use a technique, and that is we use powder. What we have is the talcum powder, white powder. We brush it across the edges of this mountain and onto the mountain. We also spread some talcum powder onto the hill. Once the ball bearing leaves from here, it goes down the hill. When it exits from the surface, it will leave a mark, and immediately we will record the mark. Okay. So we see it has left a mark somewhere here, and you can record that mark with a pencil. You need to record the angle. How to find the angle, that is demonstrated in the lab manual, theta. So the point where the ball has left a mark here, from there to this straight line where you will be measuring your B, you will record the angle theta. That you can, to record the theta more precisely, you can refer to the diagram in the lab manual. So there are two parts to this experiment. One is to see how the theta, the angle, varies by varying the distance B. Okay, so for a series of distances B, you vary by moving the slope. You record the theta, and you will plot a graph of cotangent theta versus B. That is one part of the experiment. And the next part of the experiment is to change your height, the height from which you roll down the ball, and again record the theta and see the relationship, obtain the relationship between cotangent theta over 2 versus the height from which you roll the ball. Okay, so once again I'll show you how to roll the ball. Keep it somewhere there at whichever required height you want to. Leave it. Before that, you can spray some powder onto the heel so that you can obtain the mark where it rolls down. Leave the ball, it goes down, and there it leaves a mark. You can obtain the angle by looking at the mark the ball has left.